if there is going to be a maximum or a minimum to this problem, then it must occur at a corner point of the feasible region. It will be necessary for you then to clearly identify what this point is, clearly identify what this point is, and also clearly identify what that point happens to be. It would be best if instead of guessing at that point or trying to read it off your graph, because if you don't hit the lines exactly right, you're guessing, it would be best to use our reduced row echelon command that we used back there in augmented matrices to find solutions to systems, to find the intersection point, rather than guessing at the problem. Now, once you find out what the corner points are, then being able to determine where your maximum and minimum are going to be should be relatively simple. So the corner points of the feasible region here are going to have to be 0 and 30. (24 and 0). And by using the reduced row echelon, 12 and 6. This is the new part of the stuff. Not finding the corner points, not finding where the lines intersect. That's not really new, but applying these to the end result of the new thing. If these values are possible candidates for minimum or maximum objective function, then they have to be checked into this equation. We need to determine what the value of z is for 4 times 0 and 5 times 30. We need to find out what the value of z is for 4 times 24 and 5 times 0. We need to find out what the value of z is for 4 times 12 and 5 times 6. None of which is a difficult thing to do by hand, but I know you use your calculator, and I would expect that. Well, this gives me a 150. This gives me 96, and this one gives me 78. This region out here is unbounded. It's not closed off. There is no stopping it going out to the right. There is no stopping it from going up. And an unbounded region can never have a maximum value. So it's quite possible that there may not be a maximum to your problem. It can only have a minimum. A closed region can have a maximum and a minimum. So for example, if this was the feasible region, any one of these points could be the minimum value, although this is more likely going to be the minimum, because if you make nothing, you sell nothing, then you got no profit at all. But that doesn't necessarily mean that that's going to be the minimum all the time. If it were over here, it could be any one of these 3 points that would be a maximum or a minimum. So you literally are going to have to test each one of them, which means you're going to have to find each one of them, and you're not going to be able to read it off the graph very well. So in this particular case, if they asked us, what was the original question again? We'll go back and look at the original question. Did I set up? I don't think they asked us a question there. Okay, so here, if they wanted to have a minimum value, this would be where we would expect to see our minimum function in the problem, occurring at that particular position. Now, what that means for you then is, I'm getting out of this for a second. They're going to make me log back in again. Okay, so I'm back over here. That. I'll just start it again.